So welcome to MIT's Zurich office to my talk, Leveraging the Digital Data Package for Tool-Independent Collaboration in Model-Based Systems Engineering. My name is Christoph Bergner, and of course, I would very much have liked to share this with you in person, just as we've done it in the years before, but we can't help it. At least you get a nice view of our office in beautiful Lake Zurich in spring. So this is our contribution to ProStep EVIP Symposium 2021, and I'd like to jump right into the content.
So how is this talk linked to the big initiatives within ProStep? First of all, together with the industry, we're contributing to the SysML Workflow Forum. The SysML Workflow Forum aims to compile the requirements for new solutions in the area of engineering collaboration, especially with regard to SysML. Then there is a strong link to the Digital Data Package Working Group, which is also hosted by ProStep and which targets a new format that allows to exchange cross-domain engineering data. And I can already state today that what I'm going to show today will be compliant with the results of that group. And finally, we, MIT, are contributing to the newly established SysML Implementer Forum, which aims to actually build new solutions for better collaboration in model-based systems engineering. So let's get started. I will show you some conceptual ideas first, and then we'll also see a live demo. So if we look at systems engineering today, we recognize that this world is changing dramatically. In the past, we used to exchange detailed definitions of systems purely via textual documents. Today, we're facing severe boundary conditions with an ever-increasing development pace, with massively growing cross-domain dependencies, and with a growing number of development partners in each project. So with model-based systems engineering evolving across all industries, we are confronted with new challenges concerning our development processes, our methodologies, but also the ways we interact with partners, OEMs, and suppliers. So we need efficient ways for comprehension of this complex content. We need to better understand the cross-domain dependencies, and we need a more effective collaboration. The digital data package will be an important step towards a solution of our challenges. And here I mean a package of engineering information that does not only include textual information, but also SysML models, the links between SysML models and text, and of course, the collaboration data such as comments and reviews. On the long run, there will be much more in such a DDP than shown here, but for today, I'd like to concentrate on these aspects. Now, the question is that how do we design this DDP and how do we include all these different types of information into one digital data package? Basically, we have to focus on two core challenges. Number one, how do we make sure anybody can read, navigate, and analyze the information? So how do we reach full fidelity comprehension? Number one. And number two, how do we allow authoring independent of tools and tool formats, especially looking on SysML? So if we look on the major building blocks of this digital data package, then we recognize that there is only one existing standard we would probably like to reuse, and that is RecIF, the Requirements Interchange Format. But for all the other information we have to include into the DDP, we do not have a standard. We have to invent a new one. So our guiding principles for defining a new way of collaboration in systems engineering are: number one, leverage RecIF. It is a well-established standard, it's supported by many tool vendors, and it simply makes sense to use it for collaboration. Number two, we must define an easy-to-use and implement standard for full fidelity viewing of SysML models as part of the DDP. Number three, we must include links and comments into the DDP. And number four, we want to make sure that our partners can author the information provided in the digital data package independent of tool and format, especially when we look on the SysML side. So how should this collaboration actually work? We target two infrastructure scenarios. Number one being the shared platform scenario. Here, development partners work on one shared platform, governance mechanisms grant information access on a fine-grained level, and we benefit from real-time cross-company interaction. The infrastructure scenario number two would be based on shared data. So the partners use the digital data package to compile cross-domain engineering information and exchange it via a secure communication channel. As stated before, we aim to implement two collaboration scenarios. So number one being the full fidelity comprehension. Here we want to be able to read the SysML models, the textual requirements, the textual test cases, cross-domain links, collaboration data, all from one digital data package. And number two, we want to be able to allow authoring independent of tool. This is especially relevant for the SysML content. So now let's step into the first collaboration scenario, into the full fidelity comprehension scenario, and see how we access a digital data package, read SysML models, plus textual requirements, plus links between those two domains. And yes, I'll do a real live demo in a second. So here we are in SmartFacts. SmartFacts will be one of the probably many viewers for the digital data package. And I have opened a new project. I called it DDP demo. I have added a content folder, and now we can import a digital data package into that content folder. So we just select the sample DDP we got on our desktop here and import it. Now, having imported the digital data package, we check what we got in our content folder. So all this has been imported from the DDP, and we got an Intland requirements package, CodeBeamer requirements package. We got a Doors Next requirements package, a MATLAB Simulink model, a SysML model from Cameo, and a SysML model from Enterprise Architect. Okay, so let's have a closer look what that means. So we just drag and drop the Doors Next requirements module to the right side. We select a module and we drill into the content here, expand the first three levels. And as you can see, you get rich text, you get tables, down here you get images. So this is really the content just as we would see it also in the original Doors Next platform. And yeah, let's see how we have linked SysML artifacts with those textual requirements. So we drill into the SysML model here. As I said, we have full fidelity. So this is more or less the original model tree, just as you would see it in the original tool. We go into the structure folder, for instance. We see many diagrams. We can just hover on one, get a preview of the diagram and say we want to load this to the left. And what we see is the SysML diagram, including the links to the textual requirements. So really interesting. We see directly we see the links. And what is also interesting is that this diagram is clickable, so we can select an element and we see all the model data that's associated with that element. For instance, this element is part of multiple diagrams. I can just hover with the mouse on it, and I step into that diagram where it is used. And so a very convenient way to consume the information that was transferred via the digital data package. Okay, so there's a lot more to inspect here. Of course, we can also use the code beamer requirements, just drag them to the other side, select a tracker, and yes, we see that there are also links between SysML and CodeBeamer. There are links between SysML and doors. We can even add links if we want to work with that content and enhance the information. We just quickly add links. We can wrap everything back into a digital data package and hand it back over to our partner. Good, so this is about viewing information, drilling into models, making sure that we get the traceability right, but we can also analyze and do cross-model, cross-tool analysis. So we open the analysis center, and as we have full fidelity, as we have the full set of information of our SysML models included in the digital data package, we can start, for instance, a traceability analysis, and we say we want to analyze our SysML models, and we ask if every block is somehow linked to textual requirements. And we just start our analysis, and we see there are 4 blocks only linked to textual requirements. Of course, we immediately check the opposite, which blocks are not linked to any textual requirement. We start that analysis, and we get a long list, a long to-do list we should work on with all the blocks that do not have any links to a textual requirement. So very easily, we just navigate into the content here, accelerator, this must be linked to a textual requirement. We select a requirement on the right side and generate the link. And the first element of our to-do list has been resolved. Okay, there's one more interesting thing. Every information is versioned. So I close all this, and now I will pull up the version diff, so I can just select the enterprise architect model. I will choose 2 versions to be compared. We have been provided with 3 versions of that model, and I just navigate into the details, and I see that only one diagram actually has changed. A very important information for me, because when I get a new package of engineering data, then I want to make sure that I have understood what has changed since I've seen it the last time. So here, this one diagram has changed. I just click on the lens, and this shows me all the details, and I can zoom in and understand what has actually changed. So for instance, here on the right side, in the newer version, a ECU, a class or a block has been added, while this wasn't present in the older version. So very easy for me to understand all the differences. Coming back to our overview, we have seen how convenient reading, navigating, analyzing the information of a DDP can be. Now, there is a use case that seems to be even more challenging, being how can we find a systematic approach to tool-independent SysML authoring? Some of you would say, probably, this is impossible to do, and I agree in some respect, but still we can find ways to exchange models in a sophisticated way and with good quality of transformation. And yes, we do have to do an active transformation of the model. So as stated before, the DDP owns all the relevant information. It has the model data, it has the diagrams, it has the positions of the shapes, etc. So the source of the transformation is already included in the DDP. Now we need to carry out an active transformation based on a certain rule set, and we will of course write a transformation protocol, and the result will be of the transformation will be the target file that can be read into the target tool. The characteristic of that transformation is all this is bidirectional, so we aim to provide a bidirectional migration between Enterprise Architect, Cameo, Magic Draw, and Rhapsody. Diagrams and model data are transformed. The transformation is based on a flexible rule set, so you can change the rule set that actually determines the transformation. We don't have any restriction in model size, and currently we are working with a reference model, extended age SUV model from ProStep EVIP and the SysML workflow forum. So if we go one step deeper into the details, then we find 4 process steps to do that transformation. Step number 1, we read the model data from the original tool. Step number 2, we write the complete model data into the DDP. Step number 3, we transform the data to the target format. And step number 4, we write the target format via the native API of the target tool. So at the end, I'd like to show you a round-trip example from Cameo into Rhapsody back into Cameo. So here I have a use case diagram in Cameo. This is the original diagram. We have now pushed it into a data package and read it back into Cameo. So these are the differences. Then we have pushed it from the digital data package into Rhapsody. In the next step, we have pushed it back from Rhapsody into the digital data package, and from there read it back into Cameo. So this is the 4th step. This is basically the completion of the round trip. And here is the original again. And when we switch between original and round-tripped data, then you see that there are very minor differences between the round-tripped diagram and the original one. Of course, a use case diagram is amongst the easiest thing you can transform, but still a first result, an interesting result, and we will advance on that. So we are coming to the end. What have you seen in this talk? We have put SysML models plus textual models plus links and comments into one digital data package. We have seen how convenient and powerful it can be to use cross-domain full fidelity viewers. And in the end, we have seen how we can use the digital data package as a basis for transformation to any SysML tool format. Finally, I'd like to motivate you to join ProStep EVIP SysML Workflow Forum or Implementer Forum and support this initiative with your engagement. I hope all this has aroused your interest and you had a little fun watching. And if there are any questions, I'm always happy to help. Thank you very much for taking the time watching this. All the best for you. Thanks.